Nerding and Hoarding. Quick and dirty DIY electronics.
So, welcome to this show. So, hello, are you hearing me? Are you seeing me? Are you paying close attention? So, once we are just saying, I'm so sorry. All right. So, are you hearing me? Are you looking at this right here? So, yes, you are. Today, we will design a little thing called oscillator. But not just any oscillator, I tell you. A real good one. Because it has a lot of fun things inside it. If you wonder what an oscillator is, it's something that makes electricity go up and down, up and down, up and down. So the first thing we use is a Schmitt inverter, which we can find in chips such as the 4106, which actually has 6 of these, but you know, we are on this mission to build a 10 or less, always 10 or less. So then you add a little thing called, you know, a capacitor here, which goes to a thing called ground. And then we add a little thing called what is this thing called? It's called a potentiometer. Yes. And guess what? We already have our first oscillator working. But why don't we see that? I'm sorry. New undocked scope. Yes. So are you seeing this? Are you seeing this? Oh yeah. Maybe you're not seeing it because it's so small. I don't remember how to zoom in this one. So anyway, I can tell you it works. I can tell you it works if we do like this. And the values on this one and this one you can adjust so you get a different speed, so to say. But you know, this is only a square wave, as you cannot really see here. If I do something like this, maybe you will start to see it. And just speed that up a bit. Maybe that was a bit overkill, of course. What is actually going on here? Please stop. Alright, you know me, I am always messing things up. One way or the other. Today it's not so much about a lack of knowledge, now it's more a lack of what? Yes, a lack of stimulation knowledge. So let me just change the setting here to make it a little bit faster. And there you go. Well, we just ran into the same problem as last time, didn't we? Yes, we sure did. So, okay. So, stay with me. Don't change the channel because I am actually going to teach you something today. So, there you got your first output. We can be happy with this. We have 1, 2, 3, 4 components, oscillator. But just, I will call this out 1 square. Right. But then we want to maybe if we just do like this, and we look at this right here in another scope right here, then what do we see? Well, would you look at that? Beautiful triangle wave. So how would we actually be able to use that? Well, I'm going to show you, because we do a little thing like this, which means we add a little filter on it to make it center around 0. Then we add a little amplifier to it to make it do what exactly? Well, to amplify it, of course, because if you look here in a new unduct scope, and we look here in a new unduct scope, what do we see? So would you look at this? So here we get a signal from 1 volt to -1 volt, and here we get 10 volts. You see, how beautiful is that? And if we change just a little bit on this amplification settings here, we can change the amplification, but not only that, we can also turn it into an amplification that is so immense that it turns it into a square wave. So that way we could make sort of hybrid square triangles like this. And there you go. How many components have we used now? I want to know, because you know the mission is to make 10 or less. So I said these were 4, 5, 6, 7, 8, 9. Alright, so that is maybe we have to stop there if we're doing a 10 or less, but if you're really up to it, we could do one more thing, but this is basically the 10 or less. Now we are going into sort of 15 or less territory right here. And what we are doing now is we're adding a comparator, as it is called. It means that we compare the voltage that comes here, I mean in the triangle, every value here, we compare it to a value here, and this value, we can choose this value by adding this little thing right here, which is a potentiometer between +12 and -12 volts. So what we actually will achieve by doing this is something that looks like this right here. It is actually a pulse width modulated square wave. So what we do is, when we change the value on this potentiometer, we change the pulse width right here. So you see this pulse is very short, this is a little bit longer, and if I go on changing this upwards, it goes longer and longer. See how long that is? Now it's above this one, because it depends on how high is this one actually. So now you see that is a super short pulse right there. Stop that. So, and then we get our last output, which is a pulse with modulated square. So are you seeing this right here? So, and if we have 9 components here, we get 10 with the output here. This is included in the same package as that one, so we're still at 10, and that gives us 11. So if we were actually able to remove one component, we could actually get away with this. but I'm not sure if we could do that. Maybe if we remove this one, could it possibly work? Because this is a very important job. It is its job is to, I mean, these two together, their job is to center this triangle around 0, and that's very important for both for this amplification circuit to work and for this pulse modulation to work. So I'm not actually, yes, as we see here, it actually seems to work, but we reset and try again and see what happens. So if you look here, the wave is still far above far above 0, and if you would look at this pulse width modulated part, then we would actually see if that could work. No, this is not going to fly, as they say. It is not moving right there. So we actually need this to somehow suck the energy out of there. So I will just write a little note here saying can't be included if 10 or less. Very, very nice writing right there. Alright. So that is that for the simulation part. Now let me just adjust. So like that, and we are, where are we? Yes, we are here. One moment, please. Alright, so DIY fever. DIY fever. DIY fever. It is the program of today. Today. It's very good, but it takes maybe 20 seconds of valuable screen time to load. It's almost like in the 1990s, you know, where you want to start a program and you can hear your. Okay, so there we go. We are here now, and yes. So I just did what? Yes, I got some pinouts here, and we have the schematic here, and we have the pinout for the 4106, and we have the pinout for the LM358, and this is the operational amplifier chips, and this is the Schmitt inverter trigger chips. So if we just take a little bit closer look right here, if you look at this symbol right here, and you take a look at the symbol right here, they are almost the same. If you look at the symbol right here and the symbol right here, they're almost the same, which means that we are in a good place to start, because we have what we need to start. Sorry, I shouldn't repeat that. I'm just going to write a quick note here that this is the frequency setting knob, and this is the triangle amp, and this finally is the pulse width modulation. Pulse width modulation, PWM. Right, so what do we need to do now? I will try to reduce my new method now, which is to always make two sides of the strip board, because I'm using strip board because these are chips, and I think it's easier to use chips using strip board when using chips. If we use more components with longer legs and so on, it might be easier to do it otherwise. So first thing first would be to cut some holes into this. If you don't know why I cut holes, it's to separate the different parts of the different strips from each other. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. So I plan to do like this. One chip is there and another chip is here. So this is the 4106. So what I must remember now is as follows. Yes, my new method, and it's like this, that this will actually be the blank side of the, or the sort of, you just call it the yellow side of the board. So like this, and then we will design everything on this side, and then we will make a copy of this and mirror that and put it on the side here, so we know where to solder, and here we know how to put in components. So I'm still working on this particular method. I haven't quite made up my mind about exactly how to do it, but I am working on it. So that means that it might not be perfect yet. So what I did now is cut out these right here, because this is the power header. It has positive voltage here, 12. And so we have 12 volts plus 12, and we have ground, 3 wires, and we have minus 12 like that. Just a sort of make a blank line in the program. So like this. And this, as you see here, if we're going to power the chips first, this is positive voltage right there to the chip. That comes from here and ends up there. And the same thing as this one, that also wants its energy right there. So we just pull out a line like that. So this is a bit of wire that we use to do that. So then we have sort of this and this. So what I need to do now is have a paper or another program where I can scratch out things one by one as on the schematic and pinouts as I finish them. I'm sorry, I just spilled some coffee here. I'm so clumsy, quick and dirty and clumsy. But I didn't spill it on anything electrical, I just spilled it on some plywood. So that's important. If you know you're sloppy and you are sort of always spilling coffee, so make sure to spill your coffee on something that won't break. Hello! So when I think about working with chips, I have to think in two levels. First, we think about the chip itself, and then think about the components inside. So first I think about the chip. What does the chip need to actually start working? On the first level, well, it needs positive voltage here and it needs ground there. Then we can start to use the components inside. So then first thing is to power the chips. Just setting up some housekeeping stuff right here, so don't mind that. I try to always pause you when I do it, but can't pause all the time. So this is ready right here. This is connected and this is connected. So I do this when something is connected. I highlight it with a color pen like this. You can do it with paper, you can do it with any programs, you can do it with a PDF or whatever, or Photoshop if you are like me. So this is connected now, and how do we know that? Yes, we just double check here. Is this thing right here connected? Yes, you see. This is now a net called plus 12. So the next thing to do is quite simply, we look here, what does the chip need? Well, this one needs ground, and this one needs negative voltage. So let's start with the ground, and you see here we have ground here. If I could just unhighlight that for a moment. So let's just connect every ground like this. I don't know if this is strictly necessary, but I always do it just because, can't hurt. So now all of these three are connected to each other, and then I take a third wire that goes down to here, and then up to here. So let's check our net now, and I do this by holding the Alt key and pressing left normal mouse button. So you see now we have a ground into this chip. So this chip is ready now. So let's make sure that we do like that. So now we know that it's ready. And then we will use only two of these here. Two of these pins right here, which is these points right here. But first, let's make sure that we give the second chip its voltages that it needs. So now here, minus 12 goes from here to here to here to here. So this is also ready now. And both chips are very happy, and they are ready to do their magic work for us. Ain't that so beautiful? All right. So let's then focus on this schematic right here. So let's first make sure that we know where this is in sort of the real world of the layout and what we need to connect it to. So, and that would be right here and here. And just double check which one is the bottom side or the back side of the arrow. So the back side of the arrow is right here, pin 1. So that means to pin 1 connect one side of a capacitor. We take a capacitor and we just don't connect the other side, because now we just make sure that we get one thing ready at a time, like this. So we're only here, and now we have to make sure that we can connect the other side of this capacitor to ground. So where do we have ground? If we do this quite quickly, No, I mean like this. We can see our ground is down here. Let's just pull this down here and double check. Is it really connected to ground? Yes, it is really connected to ground. And then we can do like that. But not only, but also we have two more things going on here. We have two wires going here. We don't exactly know yet where they will lead, but we just put one wire like that and one wire like this. So now we have two wires going here. We don't exactly know where they will go quite yet, but at least we have this far. And we can also decide on some colors that are not green, because green is ground and dark blue is -12 in my designs. So it could be good to make up your own color scheme. And then we see here, a potentiometer. So let's take a potentiometer. But hey, while we're at it, why don't we simply add a panel, because that would look much better. So let's see if I have any pre-made panels. Yes, I do. So look at that. There are two sides to this panel. So just make sure that we write which side is which. So I write front side and back side. Because as you know, if you turn something over, it will be mirrored. So that's important if you put components on the side of each other. You put one thing here and one thing there, but we're not doing that now. We're only putting one such thing called a potentiometer of one case value. You can very well change these values and just try. So what is important is actually the relation between this capacity's value and this resistor's value. So if you make this 10 times smaller, you can make this 10 times larger, dependent on what components you have on hand. So if we look here and we try to rotate this, just because it helps to have, doesn't really matter in this specific case, but it helps to have the same direction. So all pins are up now, and on this one it's sort of one pin is up, this pin is down, and this pin is down. So then we connect this side right here, and we'll just erase a little bit because it's starting to be messy. So what we're gonna do, connect this wire to the left leg like that. While we are at it, we might just as well add this connecting wire here, which is a short lead from here to here. Let's see, backwards. If you make a component that's not visible, it's probably behind another component. So then we have this and this and this. But where does this go? Yes, it goes to the other side of this one. So if we follow this one here, we see that the pointy side of the arrow is pin number 2. So it's right here. Right here. So we can just copy this and put that right here. Now we have these wires crossing each other, and it's strictly not necessary because there is no positive or negative side on the potentiometer, so we might as well change this. If it were so that the middle, for example, would be connected to ground, then it would matter which side is which here. So we might as well just keep it as it is, if it doesn't bother anyone. So there you go. And let's see, we have our first output as well, right there. I think this is unbuffered. I'm not sure how to call it, but anyway, we have it. So let's add a power output jack. So let's see, I have these that I use often, you know. So it's an RCA jack. It can also look like this. I made this because mine more look like this than this. This is the one that's default in the program. But you can also use mini jack because mini jack is sort of the normal one to use. So now just double check here. The pointy side of the arrow. So the pointy side of the arrow is the output. So number 2 is the output. So here we have the output. So what we can do now is take a wire either from this point right here, or from this point, or from this point, or from this point. It doesn't matter. So from anywhere. So I just do it like this. You can take any point you want. Yes, and while we are at it, this output needs every output needs a ground connector. So let's just connect that. And where do we have ground? It's all over here. So just connect it to anywhere on the ground. So we now have finished. If you want to, you can call it quits now, and you have yourself a working square wave generating oscillator. But if you want a triangle also, just keep going here. Where is this point right here? I remember now, it's pin 1. So at pin 1 we have a wire going somewhere. And we might want to actually use an extra line now, because that might help. So I am adding another line to this breadboard. So now we have the somewhere, this is somewhere, and from somewhere, which I call this line here, from somewhere we need such a thing, a capacitor to go to the positive, the non-inverting input of a operational amplifier. So like here, pin 3 on the smaller chip, pin 3 on the smaller chip. So let's see, from somewhere, this is somewhere, from somewhere to here, we need this thing right here. So we can do a couple of things. Thing that makes it a little bit more nice and good looking and slow and thorough is if you take a third, you could sort of try to get a capacitor from here to here, but in reality they don't have as long legs as these, so you probably have to put it like so, and then put a wire from here to here, and you can do that. But you can also take another line here, and you use that as another step in the somewhere connection. So somewhere is now all of these places, and somewhere is let's see, where is somewhere? Somewhere is right here. So then we put our capacitor from somewhere to, yes, from somewhere. So now that is ready, but yes, from somewhere to in non-inverting input, which is pin 3, which is right there. Oh, we have that already right there. But also from somewhere to ground, we need 100 capacitor. So where is somewhere? Somewhere is here, and where is ground? Ground is here. So from here to here, anywhere, we need a 100k resistor. So we could either put it from here to here, and then it's more easy to see what it's doing, but it's going to become a bit crowded here. So we can also put it over here, which makes it less crowded, but not so intuitive about what it is actually doing, because it's on the other side of the board. And now I'm just setting milliwatts, which is, I mean, it says here when you choose, you take a quarter watt kind, but you still have to set the quarter watt again. So anyway, that is now ready. We can double check it like so, from somewhere to ground. Yes, beautiful. So, all right. We are doing great progress. And now the inverting input, that is the one with the minus sign on it. It's right here, isn't it? Bam. So that is pin 2 on the smaller chip right here. So what is it actually we're going to do with that? So we have to check what are we going to do with that. Yes, we should connect that to the middle leg of a potentiometer. So let's just take another potentiometer here, put it down here, and yes, we actually managed to get the right correct value immediately. So from the middle leg is right there. Take a wire from the middle leg, and let's just take pink for this, like that. Okay, that is okay. This is ready, but we have to get it there. And where's there? Yes, it is on pin number 2. So you see how I tried to double check everything. So now I double check this. Is this correct? So highlight your grid, look at the pinout, and look at the schematic. So minus, minus, 2, minus, yes, going to potentiometer. But you see here, the potentiometer is pointing, the middle leg is pointing down, so we might as well rotate this just to limit our chance of mistaking the sides. Because on this it matters which side is which, because one side will be connected to ground. Let's see here. So the left leg connect to ground, and ground is here. Oh, sorry, here, but also here, because you see green here. So I just copy here and bend that like so, and that is ready right there. All right, so the last leg here will go to a point that is the point of the triangle right here, which is the output, which is 1, and it's 1, and it's 1. So you see the point of this one right here, point, output goes here, goes to this leg right there. So we just copy this, but use a little bit different color to it, so we don't accidentally mix them up. that. Bam. So then this whole thing is ready. We just need to output. So this is the output. So we just sort of copy this one right here. Copy, paste, and connect the ground. And if you are using a mini jack, it's just the same. You just need to make up your mind about you need to know what is your ground lead and what is your tip and sleeve lead. I'm not exactly sure about how they work, but often they can also be used as a switch. But just do some research before you start, and it should be no problem. You could even just connect the ground to the ground and the two of the other connectors to the signal lead. So now here, the point of the tip of the triangle is the output. That means this is the output and this is the output all the way right here. So we could either take a real long wire from here to here, or we can just take a short wire from here to here. So let's save a little bit of copper and do like this. Bam, bam, and bam. And just like that, the 10 or less version is ready. So let's see if I could write that right here. 10 or less version is ready. Alright, so I just zoom out and start to think a little bit about the layout of this document right here, because I will print it, so I want it to look nice. So I just move this for a little bit, and then I take everything of this and move it to like maybe here. So, and right, so these were things inside of this one, but I will just delete them now because I feel like it. I don't need them anymore. So just delete those. Okay. Oh, but that should even fit right there. So yes, so what I do then is no, I forgot one thing. So I just save now. Yes, I save this as 509 and 10 or less. Oscillator. Sorry for the spelling right there, but couldn't care less. Bad spelling, you know. It's square 3. 10 or less. Right, yes, but as I said earlier, for the sake of our let's say, I want this to be easy to solder, easy to lay out, easy to make it work. So there I copy everything like that. When everything is copied, I remove the upper part of the board, the yellow board, and select everything. Right click and transform section mirror horizontally. Yes, yes. So you might want to double check now if things are in the right place, because it warned me that some things will not be mirrored. I don't know what those things are, but to me it looks like it is actually mirrored. What I want to do then is take the panel, or not the panel, the board, select the board and send it forwards. So now it is forwards, and then we make it edit section, make it transparent, like this. So now we could sort of see, we still see that it is the same board, right? But it's well, just one more thing I want to do. Oh, it was this that couldn't be mirrored, so I just delete that. Yes, I just want to add small points where solder is going to be, or where things are going to be soldered. So I use this dot here. I don't actually know what it's meant to do, but you can choose how large it should be. Test that. Yes, so like this. Just put that on every solder point you want to have. That is so the end of every wire and the end of every resistor leg. And but also if you have, if I would have this one be like this and this one be like this, then if you look at it like this, it looks maybe just like one wire. But what we can do then is to actually add these points, like here, bam, 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 but on the other side, bam, bam, bam. So if I would do that, I might save one line here of board. So that could be good to do, if you want to save some board. I mean, if you make 100 things, then it's getting to add up to some amounts of board. Hope I didn't make you bored when I say bored so boring many times. This is a lot of solder points actually. I start to understand why my solder is always running out. So there you go, and let's see here, we can make it a little bit less transparent because I want to see that it is actually the copper side. So like that, and then we could just finally add a little remember note here that says component side and copper side solder here. Oh, just like that. Could even get less. So what I often want to do now is that when you print this, it's very, very, very small. So often I do like this. I take first, no, I just saw that I have remembered something extremely important right there. That is all the cutouts, these things right here. They have got lost in the copying mirroring part. So we definitely need to make them happen, so to speak. Copy them and make very, very sure you put them in the correct space. It's quite simple actually because they are under these chips right here. So you see the chips right here. You know, okay, here, 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 and here we need this kind of thing. Because this is to separate this side of the chip from this side. Otherwise, if we don't do that, you see, two different nets here will be combined, which is not good. So yes, so what I wanted to do then was to make a little enlargement of these particular make close-ups of this right here. So what I do then is first just save and then export it as a PNG file. We can call it close-up. Then I open that in Photoshop. Open. So let's see where I put that. Of course, I put it somewhere. Right, so there it is. And what I do then is to crop this like this. Image crop file, save as. Yes, just save it as it is. I mean, in that particular file, because we don't need it anymore. In another way, so, and then just import it as an image right here. And I often put it like 150% largeness, like that. And then finally, we just want to clean up the layout so everything will fit here nice and neatly and beautifully and greatly, you know. And if we have some, sometimes I make a really beautiful image for the YouTube and all that, then I can put that in here and, this and that and the other thing and the third thing. So now when I move this thing as everything right here, then I want to make sure that I actually get everything. So often I do like this. Control A, so I know that I select everything, because it's easier to move these strings one by one than maybe I accidentally forgot to move one line here, and that messes up the whole design. And I always use a code number for every build, because it's really hard to remember otherwise which is which. I always write that on the panel of the built module. So it's starting to actually look good right here. And if we take this and just make that, what do we do? Yes, send this forward so it can, transform, bring forward, so it can sort of cover up these leads that don't lead anywhere. And that is also looking good, yes. So there you go, but this one, maybe this should be here, because there will be sort of, so this is called the 10 or less version. Well, just add a hashtag just because we can, because there is hashtag on my keyboard. And then this will be please, what's going on? Alright, these are just the small little things. So this is called 10 or less, like this. And then I will also, so now I will save this file, save, and file export as PDF, Make sure it is called now. Should be easier if I call it A and B. So A, like that. 509A. Don't need to write this 2 times. Okay, I'm sorry for boring you. Yes, very much so. And then file save. File export PDF. And that will be called A. And it already says 10 or less. Yes. So now we are sort of creating a branch, if we speak in chapter. Alright, so a branch of this project. So then we do save as, and we save it as B, sort of 15 or less, I don't know. Yes, so change the name. Make sure you're in the right file here. Look. Okay, maybe you don't see that. I'm sorry, but okay, 15 or less. Let's call it 15 or less because we can. Yes. All right. So what do we do in the 15 or less? Well, first thing we have to delete that because that is a static image. And then we zoom in here. Have a look what it is that we have to do now. So on the output, second output should go to the negative input. No, the inverting input on the ship with 8 legs. So let's just see where we are. Right here. So right here, right there. And look at this. And now remember carefully now because see that it's slightly shifted here. Shifted one step down here because there is an electric input here and a ground input here, or an electric input here. So everything is sort of shifted one step down. So that is something I often mix up. So that means that this point right here is, so double check, it's pin number 6. So yes, where is the correct program? Pin number 6. How do I zoom here? Pin number 6. Pin number 6 is right here. So yes. And what did I say? The output of the second thing should go to pin number 6. So either we can take a long line from here to here, or we can take a line from here to here. Let's go with this. It's not so good looking if you do like this, but it works. So let's do that. Because we're not gonna do so much, just a little bit of doing. Then we had to also add it mirrored on this side, which is why you should always finish your whole design first. So what I will do then is just add, I have to do it. So I do this, copy it, and then transform mirror horizontally, put it in the right place, and send it backwards. No, I'm sorry. I hadn't highlighted the correct thing. Alright, send it backwards. Yes, beautiful. And then add some solder points to it. Bum and a bomb. We are on fire. Yes. So, we actually did the largest part of this thing already. This build is going to be so good. So now we just take the output of the second operational amplifier, and it's pin number 7. So pin number 7 is right here. So we just hook up a wire to pin number 7, and don't use a green because it will confuse you. Take a yellow like that, and the new output, and connect it to ground. I mean, it's ground to ground, just like that. So then finally, a potentiometer 100K. So now we're actually, if you see here, we are getting a little bit crowded here. So remember that we need almost at least 14 millimeters here. So let's say if we have 50 millimeters here, we are good to, it's possible to insert it into the case later on. And down here we also need about 50, so we have to do some comprimating, which is, yes, and this is a hassle because we are losing connections right here, which we have to reset, we fix, So you just put things together and make really sure you put every lead back in its place, otherwise the stuff won't work. Okay, I think we have enough space now for a little extra third potentiometer. Let's just copy this potentiometer here, but we put it, we rotate it just so it points like this, because I think that's how it is in the layout. Yes. So then we take the center leg. Where do we put that? Well, we put it to Control C, Control V. We put it to, double check, always double check, never try to remember, the non-inverting input, the input with a plus on it, and that is pin 5. So pin 5 is right there, so we can put it anywhere here. So I just put it, it's almost always simple to put things in the end, actually, like that. Even though it doesn't look like that all the time. Alright, so just do it a little bit like I will see the difference. Okay, and then finally, and I know I mean finally, no, it's finally. And now we only need to connect this side of the potentiometer, this right here, to a minus 12 volts. So I color code that as minus 12 volts, and this one is positive 12 volts. And remember, you can't have 1K between positive and negative, because they will just let all the power run out right straight through. Maybe it start to burn. So at least 100, you can have a mega if you want, it doesn't matter. So now the red wire goes to anywhere on this on this, what is it called? This net. Yes. So as I said, it's most easiest to connect to the outside. And this one as well, it should go to minus net, minus 12 net. And that's actually would be simplest to put it here. Or why not here? Because I mean we have still got so many leads there. Or we have already got so many leads right there. So then we just need to put a few solder points. We could even actually do it on this side just to make it a little bit easier. So if we put that right there, that means that we have it right there. And right here is right there, and right here is right there. And this one goes to, maybe we should just simply move it one step to this direction right here. Just like that, to make it a little bit nicer. And the final touch is, if you see these right here, you see that they're not exactly in the correct place. So in order to fix that, we change the project settings and we change the grid space here to hundredths of an inch instead of a tenth of an inch. And we start from the top, just simply for the sake of making it look a little better. But if you do this first, you have a problem getting things to attach to these holes here. So it's better to do it in the end, I think, or I do believe. Alright, so maybe the final thing is to add some drill holes here. Let's just take these, it doesn't matter. Like this. Oh, wait a minute, it's supposed to be like this instead. Yes. And yes, of course, I forgot some more things. I always forget something. Yes, the front side here. We might want to put some text there and some. I actually made front side knobs like this. So there's a knob. So we can actually see how it's going to look on the front side. And let's see if I have any RCA from. So these are things that I just sort of pre-made by simply using these shape tools here. Different colors on different chips. If you want to become a Patreon, I can share them with you, you know. So you see I'm using this RCA, sort of the video / audio, analog audio cables. So that looks sort of nice now, doesn't it? Just final thing right now. We add some little text about what is it actually that these knobs and things do. So this is the frequency knob. And this is the, let's just call it triangle amp. And finally the what's it called? Pulse width. Pulse. I don't know how to spell width, so just have it sort of pulse W dot. Yes, and so let's see. This is called out square, Control C, out 3, and V. Control C, Control V. No, Control C, Control V. Yes. Out. Pulse with modulated square. Alright, and with this, I say, no, you know what we forgot to do now? Close up image. Yes. Oh, yeah. It's so sad. It's so sad. Now we just do it, you know. File, save, file, export, PGM, PG, T, PNG. Yes. Close up. Close up. Yeah, what's up, my brothers? Close up, my brothers. Alright, so Photoshop, file, open. Oh. Alright. Image, crop, file, save as. Save it. Yes, replace it. Yes, smallest. Yes. Import image. Yes. Make it 150%. Yes. Click on it. Yes. 15 or less. Yes. So there you go. I will leave it like this, semi-transparent, because we don't have all, because of these wires here, I don't have the time to fix that, but you know, I guess this is quite nice and neat anyway, considering this is quick and dirty. These are a little bit irritating. At least remove them from the actual thing right here, because it's actually, no, please, no, I messed something up, I think. But you know, there's always Control Z. Control Z sets it back again, doesn't it? Yes. Alright, so this is good enough for me. File, save, file, export, PDF. Bam! Bam, bam, bam. So the good thing about this project is you can actually start with building the 509A version, and if that works okay, you can simply add the last pulse with modulation output. Yes, and you could even, I mean, there's even a chance to actually, instead of having this, you could add a second input right there to control the pulse with, instead of controlling it with the knob. So maybe I should just do like this, and write sort of, let's see, like make this sort of transparent, so you know it's like something it can be, but doesn't have to be. So yeah, yes, that's good, that's good. Control C, Control V, bam, bam. If you wonder why I say bam, it's because I think I am a cool guy. That's the only reason I say. Thinks is a cool guy. Yeah, that's fun. Alright, So like this, and I will write a little text here, and I say, if you want, you could add a pulse width modulation input instead of the port, or in addition to it. Just experiment like that. I can't guarantee it will work. Guarantee. I don't know how to spell guarantee. Guarantee, which is put 4 E's to show that I know that I can't spell it. Guarantee it'll work. So that looks like I'm using slang language like that. And then I just sort of alternative PNN. How cool is that? That is actually real cool, you know? Only a real cool guy could build something like this in his hobby, you know? Alright, so file, save, file, export PDF, replace the other one with the B, remember not to replace the wrong one, and then close this application, open Acrobat Reader, Adobe Acrobat Reader file, open and open it up. Yay! A printed file. If you're a sort of a printing person, a person who likes to print, and make sure to choose here the actual size, because if you use this, it will be slightly smaller, maybe like 95%, and that will make it so if you put a real board beside this, it's not lining up. And if you have it exactly the same size, you can very easily see if there's something wrong or how large you should cut it and so on, you know. So there you go. Just make sure your printer has some power, some electricity, and yes, I will leave you with a little beautiful jingle as always. Unfortunately, I lost the jingle playing program. So let's just see what we can do about that. File, recent, what is that? Open file. Well, I don't know. Let's just take this one.
Nerding and hoarding. Quick and dirty DIY electronics.
So there you go. Thank you.